Okay. In C++, here I have a declare one block. Here I have written one block, open brace and close brace. So within that within this block, I have declared one variable called bar. So int bar, and I have initialized that value is 2. And outside of this block, I have declared one more variable this with the same name. So that is initialized as 1. So here we have a 2 variable. One is within a block, another one is outside of that block. So, but in Java, this will properly compiled in C++. But in Java, it won't allow this type of variable declaration. So, it will show the compile time error. So, bar already, what it will show means, it will show bar already defined. So, what it will show? Bar already defined. But in C++, it will work perfectly. So here outside I have declared, outside of the block I have declared one variable called bar, and inside of the block is also I have declared with the same name. I have declared one variable with the same name bar. So this won't be accepted in Java, but this will perfectly compiled in C++. C++ allow this one, but Java won't allow this type of declaration. And next, here, this statement, this block won't be show any error. Here, I have declared one variable called bar, and within main function, I have declared the same variable bar. So here, the global variable bar, and then within main function, I have declared one more variable. Wait, 1 minute, 1 minute. Am I audible?
Yes, ma'am.
Yes, ma'am.
Okay, ma. Here, in this program, I have declared a variable within a class, and I have declared one more variable with the same name bar within main function, ma. So this is accepted. So within the function itself, if I defined any one block, within that block, if I declared any variable, that time it will show error. But this will work properly. But the previous program within main function itself, I use the same name bar. So one is outside of the block, another one is inside of the block. So this will show the error, and here this won't show. This program won't show error, ma. This program perfectly compiled. This bar is a class scope, and this bar is main function scope. And here, ma, in C++, this is an example of C++ program. Here, int I equal to 10, and within that for loop, I have declared the variable int I equal to 0. So this is accepted in C++. Have you seen this type of declaration in your C++, ma? Say yes or no, pa. Have you?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes,
this type of declaration is allowable in C++. Within main function itself, you can declare I variable more time, but this I is for loop I, and this I is main function, right? But in Java, within same function itself, we cannot use the same variable 2 times, ma. But here, if I in this on right hand side is the Java program. So in that Java program, I have declared a variable I within main function, and within that for loop also I try to declare the variable I. So now what I will get I variable I is already defined in main method. So I got the error in Java program, but in C++, I won't get any error. It will perfectly compile and execute. But in Java, I will get an error. But in different function, I can have same variable name. So a different function, and outside of the class, I can have same variable name. But within the same function, I cannot use the variable more than one time. I cannot declare the variable more than one time. Understood, Appa? Within a function, you cannot declare the variable more than one time. Even if you declare the variable within a block, it won't be accepted in Java. But in C++, it is accepted. And then type conversion and casting. So this is similar to your C++. So Java's automatic conversion. An automatic type conversion will take place if the following two conditions are met. The two types are compatible. So when automatic type conversion is met, automatic type conversion is possible means the two types are compatible. The destination type is larger than the source type. This and all similar to your C++. So what does mean by compatible? So characters can never be converted to Boolean type because both are incompatible. So what is the destination type is larger than the source type. For example, if you want to convert byte to integer means when compared to byte, integer, the destination type is larger. When compared to byte, the destination integer byte to int means here which is in destination, which is source means byte is the source and the integer is the destination. So that the destination type should be larger. So then you can then automatic conversion is possible. Automatic conversion is possible. Byte to int possible, byte to double possible, byte to float possible. All those things are possible. So when automatic conversion is performed means if two types are compatible and then the destination type is larger than the source type. And then casting incompatible type. For example, if you want to convert integer to byte, if you want to convert from integer to byte means in C++ you have used a type conversion operator. Have you remembered that one, ma? Have you remembered that one? If you want to convert from highest type to lowest type, integer type to byte type means in C++ we have used a typecasting operator. Have you remembered that, pa? Say yes, sir, no, ma?
Yes, yes, ma'am.
Yes, ma'am.
Very good. So here also we are using the same typecasting operator. Here also we are using the same typecasting operator. So when int is cast to byte variable, actually what is the size of integer in Java? 32 byte. In what is the size of byte? 8 bit. Int size is 32 bit. Byte size is 8 bit. So the result is the remainder of the division of int value by 256. So how we are converting integer to byte means the result is the remainder of the division of int value by 256. So we will see one example. When double is converted to byte, its fractional component is lost and the value reduced modulo 256. So let's see one example. So here, actually, what is this 50? 50 is the constant value. So now this B have value 50. So what is the range of byte? That is 8 bit. So you can store only 0 to 255. You can store only the value 0 to 255. That is 2 power 8, 256. So totally we can have a 256 value. So that is 0 to 255. Now when I multiply when I multiply this byte variable B with this 2, I will get an error. Even what is the solution of this B into 2, ma? What is the value of this B into 2, pa? B value is 50, 100. So that is within the range 0 to 255. What is the range of byte? 0 to 255. So that after even multiplying, I will get the value within the range of that 0 to 255, even though I will get an error, because when I am performing any operation in expression, that all the byte and all the byte variables are all converted to integer automatically. So in expression, all the byte variables are converted to integer automatically all the byte variables are converted to integer in an expression. So now actually the solution result is integer, but here the variable type is byte, destination type is byte. Here the solution we got in the type integer. So here conversion from integer to byte type. So destination type is smaller. So that's why here we will get an error, cannot assign an int to byte. But here also, here I have a 2 byte variable B and C. I'm multiplying B and C. So even both type are byte and the destination is also byte. I cannot get the result. I will get an error message. So what does that error message means? Cannot assign an int to a byte. Why? Because in expression, the byte are automatically converted to integer. In an expression, the byte values are automatically converted to integer. Java automatically promotes each byte short or char operand to int when evaluating an expression. Java automatically promotes each byte short or char operand to int. What are the types are all converted to int? Byte, short, or char operand to int when evaluating an expression. For example, here byte equal to 50. Here the result in the form in integer form I will get the result, but I'm typecasting that to byte. So then that is going to be stored in this B. So this won't show any error, This won't show any error, but this statement and all will show error. This statement and all. So this statement and all will show error because in expression, the byte values are converted to integer automatically. So the integer result cannot be stored in byte variable. And here also the integer result cannot be stored in byte variable. But here the integer result are typecast to byte type. And then that result can be stored in this byte variable. And we will see one more example. Here I have a 3 variable, byte and then int and then double. So byte that I value is 257 and this D value is 323.142. So now I am converting that integer type to byte type. So what is the range of a byte type? The byte type range is only 0 to 255. But what is the value of I here? The I value was 257. So how can I store the 257 within that B means? Already I told you, so we have to take the modulo value for this 257. So what is the value of modulo 257 mod 256? That is 1. We have to take the modulo value of this. We have to take mod 256 for this 257. So then we will get 1. So that is going to be stored in this byte variable. That is going to be stored in this byte variable. So actually the byte range is 0 to 255. But here that I value is 257. So I try to store the 257 into this B variable. It is not possible. So how it is stored means by taking mod 256, the value is stored in that byte variable, and then it will print I and B. What is the value of I? I value is 257. But what is the value of B? So that B have 257 mod 256. So that is 1. So that's why it will print conversion of int to byte, that I and B, that is 257 1. And then system dot next conversion of double to int. So how the double variables are converted to int type means this after the decimal point, these values are truncated. Only the 323 is going to be stored in this IMA. So that after decimal point and all the values are truncated, only the value 323 is going to be stored in this variable I. So now it will print D and I. What is the value of D? That is 323.142. And then it will print the I value was only 323. Only it will print 323. And then how the double type is converted to integer byte type means, how the double type is converted to byte type means that after decimal point value, the values are truncated, and even truncated, this 323 cannot be stored in this variable B because the range of the byte value is 0 to 255. The range of byte is 0 to 255. So we have to take the mod value for the 323. So 323 mod 256, we will get 67. We will get 67. That is going to be stored in this variable B. Ma, understood about the conversion?
Ma'am, one doubt, ma'am.
Tell me, ma.
Ma'am, if I is something less than 255, what will B will become?
As it is, the value is stored, ma'am. Even if you take it at 255, if you have value 255, means 255 mod 256 again 255, no?
Okay, ma'am.
Okay. Any other doubt, pa?
Ma'am, can you explain the last double 2 byte?
Double 2 byte. That double value, actually, the double value is 323.142, no, ma? This D value is, so that a point after the decimal point, that value is truncated. And then we have value 323. So that 323 is also out of range. That is, what is the range of byte? 0 to 255. But 323 is also out of range. So then what will happen? It will take the mod value of 256. 323 mod 256. That is going to be stored in BMA. So 323 mod 256 means you will get 67. Got it, Appa?
Thanks.
Any other doubt, ma? Okay, understood, Appa. This one. Shall I move to next topic, pa?
This one.
Ma'am.
Tell me, pa.
Ma'am, you have stored D as 323.142, ma'am. How
yes,
is it printed like that, ma'am?
How it is printed, Appa?
Yeah, yes, ma'am.
This is a constant value, no? So this is a constant value. By default, the floating point literal is a double, pa. Okay, va? But here, instead of a double D, if I am giving a float F, I will get an error because by default, the literal values are a floating point constant, sorry, the double constant. So here 323.142, it is as it is, it will display, pa. What's your doubt, ma?
No, ma'am. In the last line of output, conversion of double to byte, D and B you have given, ma'am. So for D, 323.142, ma'am. How it came for D, 323.142, I'm asking, ma'am, actually.
Yeah, D value here, I have initialized the 323.142, no, ma?
Okay, ma'am. Okay, ma'am. Okay, ma'am.
Okay, Papa. Understood, Papa. Shall I move to the next topic, ma?
Yes, ma'am.
Okay. And then we will see all the types within one single expression, pa. So the type promotion rules. So for here I have a byte type and then character type and short type, and here one integer type, floating point type and double type. So here I have a mixture of all the types. So now, ma, in this expression, which is going to be executed first means the bracket statement are all going to be executed first, ma. So that is also from left to right. So now which is executed first means that F into B is executed. Which is executed first? F into B. Pa. So what is the type of F? F type is float, B type is byte. So in an expression, if we have an integer, float, double means which is have a higher range type, double. So all the variables are converted to double type. So like here, I have a two type. One is floating point type, another one is byte type. So here, which is higher range type means that is floating point type. So this B is converted to floating point type, and that type is going to multiply with this floating point type. Then what is the result become? The result is finally the result become floating point. Finally, the result become floating point. And then that is a B is promoted to float. And then in this expression, so next to this bracket is executed. So in this one, C is promoted to int. C is promoted to int. And then in this expression, S is promoted to double. In this expression, S is promoted to double, because short type, S is the short type, and this short is converted to double. So finally, this first bracket result is in float, and the second bracket result in int, and third bracket result in double ma. So finally, I'm going to add float. First, I'm going to add the float and int value. First, I'm going to add this float and int value. So now that int is converted to float, and I'm going to subtract the float. I'm going to subtract the double value from float. So now, what is the result of this one? Double. Understood, Appa? When I multiply f into b, what is the type of f? Float. What is the type of b? Byte. So now here the b is promoted to float. Ma. When I am dividing I by c, what is the type of I? That is integer. What is the type of c? Character. So now c is promoted to int. When I multiply double and short type, the short type is promoted to double. When I am adding float and int, that the int is converted to float. Finally, the result to become float. Float minus double, I will get result in double type. So finally, what is the result type? The result type is in double form. Understood, Appa? This and all similar in your C++. This type promotion. Got it, Amma?
Yes, ma'am.
Okay. Okay, pa. Next, we will see array concept. When compared to C++, here array concept is somewhat different. In that declaration, variable declaration. Here, how we have to declare the array variable means type var variable name, and then you have to use that open square bracket and close square bracket. In C++, you can declare variable like this, no? Int var 2. But in Java, if you try to declare array variable like this, you will get an error message, int var 2. How you have to declare? Only you have to declare int var and then the bracket. You have to declare the variable like this, int var and then the bracket. Got it, Amma? But this is okay. After the declaration and initialization, both are same in the same place. So this is okay in Java as well as this is okay in C++ also. But in C++, you can declare variable like this, int var of 2, array variable. But Java won't allow this. So how you have to declare the variable means, you have to declare the variable like this, ma. Okay, into months of days. This is a variable name, month, days. This is a variable name. And then after that, only you have to specify the after declaration, you have to specify the size by using runtime, by using dynamic memory allocation, new operator. First, I have declared the variable. After I have declared the variable, I have allocated 12 integer variables. And then next, in this place, I have declared as well as I have allocated memory for that array. So this is also okay. But this type of declaration is not possible in Java. You have to declare with this empty square bracket. So after that, you can initialize, you have to create a memory by using a new operator. And this is also possible at the same place, but here you have to use one square bracket. Actually, mistake is there. So here you have to use, if in the same place, if you are declaring means you have to use square bracket. So here also square bracket is missing. So here also one square bracket and here also one square bracket. Got it, Appa? Array declaration. Understood, Appa?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes,
Here,
ma'am.
very good, ma. So here I have declared the variable. So after declaring the variable, I'm going to allocate memory for that array variable during runtime by using new operator. So while allocating that variable, that time you no need to use that square bracket. That time you no need to use square bracket. But while you declaring the while you declare in the same place itself, you're going to allocate memory means that time you have to use the square bracket. But here, once I have declared, in the next statement, I'm going to allocate memory means only use the variable name is enough. Variable name equal to new into 12. And then next, I'm going to initialize the values. Initialize the values. So this is also, this type of initialization is also possible in Java. So like C. So what is the size of this variable? 2. Automatically, the size of this variable is 2. Understood, Appa? Got it, Amma?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
Next, I will move to average, and this is an example by using a single dimensional array. So this type of declaration is possible. While you declaring that array in the same place, you can initialize. So this is possible. And then now what I'm doing, I'm adding all those value, and then I'm going to find out the average of the value. So finally, I will get this as the result. So within the main function, I have declared and also I have initialized the variable. And next, multi-dimensional array. So in the same way, how we have declared and how we have allocate memory for array, for one-dimensional array, in the same way we have to declare and allocate memory for multi-dimensional array. So this is an example two-dimensional array. So in this way, you have to declare and allocate the memory for the two-dimensional array. So here, what is the size of this array? 4 cross 5. So what is the size of this matrix? 4 cross 5. And now I value is 0 to 4 and j value is 0 to 5. So then one variable k, I have initialized the k variable as 0. And after every iteration, this k value is incremented by 1. So that's why the array, the two-dimensional array is going to have value 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because here totally totally how many number of elements we can store? We can store 20 elements because the size of the matrix is 4 cross 5. So 4 cross 5 means 4 into 5, 20 elements. That's why here 0 to 19. So here the k values keep on incremented, and so in the same way, how you have created the memory for one-dimensional array, in the same way you have to create the memory for two-dimensional array also, and after that you have to initialize. And next, that in your C++, that each row, all the rows should be the same size, no? In C++, that all the rows should be same size. For example, in my matrix, if I am in this example, I have 4 rows. In the 4 rows, that all row size are same. In all row size are same. The first row size is 5. Second row size is 5. Third row size is 5. And fourth row size is 5. So all the row size are equal in C++. In Java, but in Java, we can vary the row size. We can vary the column size. So first row size, in that first row, I can store only, if I want to store 3 elements only in that first row, I can make it, the size of the first row is 3. If I want to store only 2 elements in the second row, I can make it the second row size is 2. So next we will show, I will show one example for that. Here I have declared one two-dimensional array. And then here I'm not mentioned the column size because here in each row the column size is going to be vary. So that's why here while I'm declaring, while I'm allocating, I'm not telling the column size. So now for 0th row, I'm going to allocate only one element, one integer element. For column, for row 1, I'm going to allocate 2 integer element. For row 2, I'm going to allocate 3 integer element. For row 3, I'm going to allocate 4 integer element. So in the first row, I can store 1 element. In the second row, I can store 2 element. In third row, I can store 3 element. And fourth row, I can store 4 element. So here also k values keep on incremented, and I have stored that k value in that two-dimensional array. So here that for loop, how many number of rows we are having? 4 for loops are we are having, sorry, 4 rows are we are having. So that's why this outer for loop is executed from 0 to 4. And then that inner for loop, in that first row, I have 1 element. In the second row, I have 2 elements. So that's why that second row index variable, control variable based on that I plus 1. When I value 0 means 1 element. When I value 1 means 2 element. So now like that, I stored the elements in an array, and then finally I got output like this. So in that first row, I have only 1 element, 0. In second row, I have a 2 element. In third row, I have 3 element. In fourth row, I have 4 elements. Understood, Appa? This one you understood, Appa?
Yes, ma'am.
Yes, ma'am.
Differing
Yes,
size.
ma'am.
Okay. So this is possible in Java, but this is not possible in C++. You can vary the size. Second dimension size, ma. You can vary the second dimension size.
Ma'am.
Tell me, pa.
Ma'am, in C++, we have to give either row or column, means one value we have to provide. So in Java also we have to provide one value,
No. In C++ also we have to mention that row size. We should mention the row size.
Yes, ma'am.
But in need not to be mentioned the column size. But here also in Java, you need to mention the row size, ma. You should mention the row size.
Okay, ma'am. Okay, ma'am.
Okay. Shall I move to the next one, ma?
Yes, ma'am.
Tell me, pa. Tell me.
Empty the row size and leaving blank and specifying column size, it will give error.
Then what is the purpose of that row?
Okay.
Okay. Shall I move to next, pa?
Ma'am, I have a small doubt, ma'am.
Tell me, ma. Tell me.
Ma'am, when we try to access, for example, here in the first row, we just have one column, right, ma'am? Just one element.
Yes,
In case if I try to print the next position, will it show an error or will it print a junk value, ma'am?
No. That the next position value was the first position value was 0. So what is the next position? Position means the position of 1 is the next position. It won't show any junk value. It will show the position of that 1.
No, ma'am. Like, for example, I'm trying to print 2D of 0, 1. Now, what will it print, ma'am?
Oh, you are asking here in Java, there is a strict array bound checking is there. In C++, there is no array bound checking condition.
Yeah,
but in
that was
Java,
my doubt, ma'am.
Okay, you will get an error.
It will show an error. Okay.
You will get an error because in Java here we are getting a strict array out of bound checking condition.
Okay, ma'am.
Okay.
Thank you, ma'am.
Okay, pa. And the next, while we declare the two-dimensional array variable, that time itself we can initialize. How we have to initialize means we have to put open bracket and close bracket semicolon. So within that, this represent the first row value. These are all represent the second row value. And these are all represent third row, and these are all represent the fourth row. So that for every row, you have to put one open brace and close brace. After that, you have to put one comma. So that every row are separated by the comma. Then finally, here I try to print the two-dimensional array value. So I will get output like this. So got it, Appa? How you while we declare the two-dimensional array, that time itself I can initialize by this and syntax open brace and then close brace semicolon. So within that each row are represented by the open brace and close brace. So then that every row are separated by the comma value. Got it, Appa? This one you understood, Amma? Tell me, Pa.
Ma'am, in the previous program, ma'am.
Tell me.
Not the previous. And it, ma'am, how it is going to the next row, ma'am?
How it will go into the next row? Here, what is that I value initially? 0, no? I value 0. For when I value 0, this J loop is executed for only one time. J loop is executed only one time. So then after executing that one time, this is terminated. So then I value is incremented, no? So then it will go to the next row.
Without any slash and also?
Here we are using a println statement, no? After printing this here a print statement, here a println statement. So when this inner for loop is get over, it will insert one new line, ma. When inner for loop is get over, it will insert one new line. Got it, Appa?
Okay.
Okay.
Yes, ma'am.
And the alternative array declaration, you can declare array variable type, integer type, and then square bracket variable name. So here, this is one way of normal way of declaration. So you can also declare in this way, pa. A type square bracket then variable name, pa. So usually how we declare means type variable name square bracket. This is also possible. Type square bracket and then variable name. Got it, Appa? So like the following declaration is also equivalent. This is a two-dimensional array. So you can use that square bracket after the variable name, or you can use the square bracket after the type variable, type, data type, after the data type. And this way of declaration is also possible, pa. Int square bracket. When this type of declaration is more useful means here I'm going to use only one square bracket. After that I have used three variable name nums2, nums3. So now all three variables are array variables, pa. Create three array variables of type int. But after variable name, if you are using square bracket means for after each and every variable, you should use that square bracket. Got it, Amma? When this type of declaration is useful means only one time I have used the square bracket. So after that, I have declared all the array variables only by separating the commas. So now here three array variables are created. Understood, Appa? This statement is similar to this one. Okay. Next, in Java, does not support a string. There is no primitive data type string. But as in our C++, we have a string class. No, that string data type are going to be act as object. So here also string type called string. String means class. S is a capital letter, so class. So it's not a primitive type. String defines an object. So the string type is used to declare string variable. Here a string is not a primitive data type. It is an object. So as like your in your C++. So here string is the object. Understood, Amma? Understood, Amma? Shall I move to the next topic, operator? Pa?
Yes, ma'am.
Up to okay, I will move to the next topic, operator. This is visible, Appa? Is this visible? Operator slide?
Yes, ma'am.
Yes, ma'am.
Okay, ma. Here also we have four type of operator as similar in your C++, ma. Arithmetic operator, bitwise operator, relational operator, and logical operator. These are the example, some of the examples of arithmetic operator, ma. So that arithmetic operator cannot operate on Boolean types, ma. So cannot use them on Boolean types. So these operator we cannot use them on Boolean data type. And here in your C++, this modulo operator can only work with integer data type. But in Java, this is also can be work with the floating point number and double number. Got it, Amma? For example, 2.25 mod 10 means it will give result 2.25. 14.25 mod 10 means it will give 4.25. But C++, that mod or modulo operator can be worked only with integer data type. So we cannot work the modulo operator on floating point type and double point type, but in Java it is possible. The modulo operator can be worked with the floating point type. Got it, Appa? Arithmetic operator cannot be worked with the Boolean type. And then here the modulo operator can be worked with the floating point type also. So got it, Appa? Shall I move to the next type, bitwise operator, pa?
Yes, ma'am.
Okay. Yes, ma'am.
Okay, ma. So next, bitwise operator. So these are all the bitwise operator. So some of the new these operator already you are familiar with in C++ itself. The new operators are all shift right zero fill. These are all the shift right zero fill assignment. Shift right assignment already you are familiar. This shift right zero fill. So and shift right zero fill assignment. These type of operators are new in Java. So I will show you example for those operators. Here, Java, how we are representing a negative number in Java means, how we are representing negative number in Java means by using 2's complement. I will explain what is called 2's complement. I want to represent number -8. I want to represent number -8. So what is the size of integer in Java? What is the size of integer in Java? 32 bit. 32 bit. So now for to represent the number 8, I need 32 bit, and this is the binary representation of 8. So 2 power 0, 2 power 1, 2 power 2, 2 power 3. So 2 power 3, 8. So this is the binary representation of 8. I want to represent -8. I want to represent -8 means I have to take 2's complement for this binary number. So how what does 2's complement means? You have to take the first complement. So what does mean by first complement means? You have to convert 0 to 1 and 1 to 0. So here all the zeros are all converted to 1 and this 1 is converted to 0. All the remaining zeros are all converted to 1. So this is first complement. So what does a 2's complement means? After taking the first complement, you have to add 1 with that first complemented value. Okay, so if I am adding 1 and 1, I will get 0 and then carry 1. So 1 plus 1, 0, and then 1 plus 1, 0, and then 0 plus 1, 1. Okay, so then this is the representation of -8. Understood, Appa? Actually, in binary addition, 1 plus 1 means binary addition. 1 plus 1 means I will get binary can have only 0 or 1s. So 1 plus 1 means I will get 0 and then I will get carry 1. So that will come to here. So again 1 plus 1 0 and carry 1. 1 plus 1 0 carry 1. So now 0 plus 1 1. Understood or not? Got it? How -8 is represented in Java? Got it or not?
Yes, ma'am.
Yes, ma'am.
Okay.
If I give any number, integer number, can you able to convert to negative value? Can you give the negative binary representation for that number? In exams,
Yes, ma'am.
they may ask you to write the binary representation of -7, -8. Like that, if they have asked, can you able to write? First, you have to write the binary representation of the positive value. After that, you have to take the 2's complement for that binary representation. So that is the negative representation of that number. Got it? Got it or
Yes,
not?
ma'am.
Okay.
Yes, ma'am.
Okay. And next, this an right shift operator. So this and all already you have studied in your C++ itself. So no problem. I will show you an example. Here I declared one variable, integer variable, and I have initialized that integer variable as 35. So what is the binary representation of that 35 means? This is the binary representation of the 35. So that is 2 power, this is 2 power 0. So 2 power 0 means 1. And here 2 power 1. So 1 plus 2, 3. 1 plus 2, 3. And this is 2 power 2, 2 power 3, 2 power 4. This is 2 power 5. So 2 power 5. So what is the value of 2 power 5? 32. So 32 plus 2 plus 1. That is 35. So binary representation of this 35 is, this is the binary representation. And then next I'm going to do the right shift operation. So right shift means this one is shifted here and this one is shifted here. So at the last I have a free 2 space. So that space is filled with here at LSB, sorry. And at most significant bit, what I'm having, I'm having 0. So while I am shifting right side, 2 empty spaces, 2 times I'm shifting. So 2 times shifting, so this one will come here. this one will go out. This two ones are go out, and then this 0 fill this place, and this 0 will fill this place, and this 0 will come to this place, and this 1 will come to this place. So like it is keep on shifting. So finally the last two spaces are free. That last two space, how it is filled means, in that most significant bit what we are having 0. So that empty spaces are filled with that most significant bit. Ma. Got it? So finally what I will get? I will get 8. Understood, Amma? Got it, Appa?
Yes, ma'am.
Yes, ma'am.
If I have 1 in most significant bit, what will the 2 empty places fill with?
Then all the empty spaces are filled with 1. Ma.
Okay, ma'am.
So here, this is the -8 representation. This is the -8 representation. And I am shifting right shift 1 means, here an example, no? Here empty space I am having. After shifting 1 bit to right side, I have one empty space, no? That empty space is filled with 1, because here what I am having, I am having 1 at the most significant bit. So that's why here 1 is filled. Got it, Appa? Got it, Amma?
Yes,
When shifting right, the top leftmost bit exposed by the right shift are filled in with the previous contents of the top bit. So this is called a sign extension. So that's why the sign is not changed. If most significant bit is 1 na negative, if most significant bit is 0 na positive. So here the most significant, that empty space is filled with that most significant bit while doing a shifting process. So that's why it is preserve the sign. So this is called a sign extension. This is called a sign extension and serve to preserve the sign of negative number when shift them to right. Got it? Got it, Pa? Yes or no, Pa?
Yes, ma'am.
Ma'am,
Tell me, Pa.
ma'am, here the most significant bit is 1, no, ma'am?
Yes, ma.
So that 1 represents minus sign, ma'am?
Yes, ma.
Okay,
yes.
ma'am.
If you are shifting a -1 any number of time, what will happen, ma? If you are shifting a -1 right shift, what will happen? Always this 1 will come here and this 1 will come here. Always the empty spaces are filled with 1, ma?
Yes.
Got it or not, pa? So then any number of times if you are shifting -1, always you will get what? Final result is always -1.
-1.
So that's why the next new operator, I told you, Nama, one new operator is introduced in Java, that is shift right 0 fill. So instead of filling the most significant value at the empty space, it is going to fill 0. Ma. Got it? So here three symbol. Here only we have a 2. 2 symbol, 2, what is it, less than or greater than 2 times we are having, but here we are having a 3 times, ma. So this is called shifting with the 0 fill, right shift with the 0 fill. Understood, ma? So 24 times I'm shifting that -1. So after that, the remaining, the 24 bit, I got a 24 empty space, no? That 24 empty spaces are filled with what, 0. So then I will get the positive number. So what is the representation of what is the decimal representation of this binary number? That is 255. Got it? Understood, Appa?
Yes, ma'am.
Yes, ma'am.
Okay. And then next class we will see left shifting operator, ma. Up to this, do you have any doubt, ma? No doubt. So the next class we will see left shifting operator. Ma, have you downloaded any JDK version, pa? Have you downloaded JDK version? I will come to chat window.